Hello guys, welcome back to the channel leet-code and sleep. And today's leet-code problem is the extension of the previous day's problem here, and this is an optimal approach of the brute force problem here. And this problem is as I already discussed in the previous video, and well, let us quickly dive into the problem. Okay, so there are given string of array, and we need to concatenate every subsequence of array, and we need to form a string so that it doesn't have any unique characters here. So we have to return the maximum possible length of a string here. Okay, so here is a array. We have to add these subsequences to a string, to an empty string for a suppose. So we need to find the maximum length of the string such that it does not contain any unique characters. Okay, so this is the problem here. Like in the previous video, we have solved this problem using recursion, right? So in how many ways we can solve this, and by after concatenating uh, all the possible ways, we have to check, right, whether it contains unique characters or not. We have checked that, and accordingly we have did the problem, right, and we have find the maximum length by using recursion here. Okay, so now we will be using bit manipulation here and plus recursion here. Okay, so bit manipulation plus recursion here. Okay, so now how to use bit manipulation here. So for example, the starting step what we will do is here we will bifurcate these substrings, like whatever the subsequences are there here, we'll first bifurcate them. So we'll bifurcate in such conditions, like it should the subsequent should not contain any should not contain any duplicate characters in it, right? So this subsequent should be in unique form. So that means the substring should have all the unique characters in it. Okay, so uh, first of all we will bifurcate this thing and we will do this thing. Okay, and next we will convert whole string to an integer value. Why integer value here? So because we can convert it, right? So because the substring contains, the ultimate goal of our substring is to, it has to have a unique character. So each character has a haskell value, right? And the integer range can be up to 32 bits, right? So uh, and the characters can only be 26 characters. So in an integer, 26 character can be fitted, right? So according in an integer value, according to that character index, we will be doing the bit manipulation here. Okay, so we will be doing the bit, we'll be changing that bit number. Okay, so we'll be doing the set bit. Okay, initially we will be taking a zero integer with 32 bits, and accordingly by going each character of a string, and we'll be modifying that, or we'll be doing a set of that bit. Okay, we'll be doing bit set. Okay, so first of all we'll try to perform this problem. So okay, so I have taken this array, right? So I need to convert this substring to an integer, right? So what will be the character of so I need to convert that string to an integer, right? So I will store an integer in place of this string. Okay, so that's the main thing. So what should I do for that? I need to go I need to go to every character of that string. Okay, so I'll take u here. Okay, for u, the value is 21, right? The in the alphabetical place the value will be 21. So so okay, 21, and n will be 14 here. So 21 and 14th bit of an zero integer will be set here, right? Will be set here. So in this we have to do this thing. Okay, this is the char set I'm taking, that is initially 0, will be 0th integer, we will be converting that 0th integer bits to set bits. Okay, according to the character. Okay, so the u character is 21 bits, it has 21 numbers, so we need to have a mask here, mask 1, and we need to left shift it to 21 times and do the and here, and for char set here. Okay, When we do AND for char set, what we'll get? If it is a 0, and we need to add it to the char set. Okay, so let us do that thing. Okay, so let us do the thing first. So what am I doing is, so I'm taking a zero at the zero integer, and I am taking a mask here. Okay, I'm taking a mask and I'm taking the value of u here. So I'm taking the value of u and left shifting the mask, the one mask to 26 times left shift. We will be left shifting 21 times, 26 times. I mean 21 times the the character index times. We will be left shifting it, and we will be adding it to the zero integer. Right, that is char set variable, char bit. I will add adding to the char bit variable. Okay, which is the original array, original integer. Right, it will be the original integer for us. Okay, and if you add that, it will be, now it will become the answer of that original string, original integer will become that set bit, right? 21 set bit, right? So we'll perform it by using this algorithm here. Okay, how we can do this? By performing by using this algorithm here. Okay, so by doing this, how we can identify whether there is a duplicate or not? So we can identify whether it is a duplicate or not. See, so here 21 is already present, right? So we have gone to 21, and we need to convert these to 1, right? So I have converted my char set to 1. Okay, so I have converted, this is my original string, original integer. Okay, so I have left shifted my mask to 21 times, and I have added it to char set, and I have I did char set, char bit, char set, or mask. Okay, so if I do this thing, this 2 gets added. Okay, what is the char set or truth table? 0 plus 1 is 0, 1 plus 0 is 0, right? So whatever, so initially it was 0, so 0 plus 1 is 1, right? So it will be the char bit of char set will become 1 bit, right? So, and again n equal to 14 here, so we need to move our one mask to 14 times left shift. We need to do left shift or marks 14 times, and we need to add it to our char bit, right? So when we add it to the char bit, this bit will become 0, right? 1, right? So because initially it is 0, so 0 plus 1 will become 1 here. Okay, now I what will I, initial our marks will be 1, and we need to left shift our 1 to 9 times, right? So after left shifting our 1 to 9 times, it will be here, and we need to uh, or it with char set, right? And here it is 17. Okay, 17, 21, 20, 19, 18, and 17. So this bit will become 1, right? So this will become 1. Okay, and 21 here. So here again we have come with 21 here. So what will be the answer here? It will be, it will be greater than 0, right? So whenever, to check whether there is a duplicate or not, we need to AND it with char set. Okay, for checking, for checking duplicate, we need to add char set and mask. When we do this thing, what we'll get? Initially we need to, if there is no duplicate, we need to get 0, right? So because if you want to place a set bit here in the 0, 1, 2, 3, 4, 5, in the fifth bit of original integer, we need to place a set bit here. So to place a set bit, there should be no duplicate, right? So when we try to do the AND with char set with our mask, then the value should be equal to 0, right? So 0 into 0 and 1 will be in the truth table, it will be 0, right? So if at all it gets 0, then we can add it to our char set, right? So if at all there is a negative number, there is greater than 0. So if it is greater than 0, then the integer is greater than 0, then what we can say, the there is a duplicate, right? We can say that there is a duplicate already present, so we don't do the we uh, we don't we should not do anything there, we should return from there, right? We should not uh, so from this we can say that that string is a duplicate string, so we need to not consider into answer, right? So we need to ignore that string. Okay, so in this case in this way we will be ignoring that string. Okay, and so this is how we'll be solving for we'll checking for the duplicate by adding it with the mask. If it comes to 0, then only we can add it to our original integer. If at all it is greater than 0, that means it has a value or it has a duplicate there, then we should not add it to our original string and original integer, and we need to ignore that string, right? So this is how this is what we did here, right? So I'm traversing over the every character uh, of a uh, of a string here. Okay, and I'm taking a mask value 1. Okay, and I'm left shifting the mask value to s dot caret I minus character a. Okay, these many times I'm left shifting my mask value. So, and I'm checking it whether my char bit and the mask value is equal to 0 or not. Okay, if it is greater than 0, then I'm not allowed to do anything, right? Because it is a duplicate value, so I'm not allowed to do anything, so I'll be returning from here. Okay, so or else I can add it to my original string, right? So original integer, right? So I'll add it to my original array, original integer, that is char bit. Okay, so after adding every bit to the original integer, now what we need to do? So if you carefully observe here, in the 32-bit string, okay, in the 32-bit integer, there are we are only using 26 bits of integers, right? So the remaining six integers are 6 bits are left are left not used, right? So are left not used. So there we can store our length, right? So length of our string, right? So whatever the length of our string, so we need to have the length of uh, we need to what we need to return the maximum length of the string, right? So we can store that maximum length uh, instead of having another variable in that integer only. We can store that maximum length in that area, right? In that 6 bits, right? So what we'll do is we will be storing the length of the string which is not duplicate in nature. That means it doesn't have any duplicate characters in it. So it doesn't have any duplicate characters in it, so it is a valid string. So then we can store its length in the 6 bits, last 6 bits of the original integer, right? Because it is not used, so we will use it and we will store it with the length here. Okay, s dot length. So 21, 22, 23, 24, 25, 26. So up to here we are using it for storing our characters, right? Characters, like we are using it for storing the characters, right? So and we are not using these bits anytime, we are not using these bits anytime, so we will use it now for storing the length here. Okay, so we will be storing the length in this 6 bits. Okay, how to store that? So we will store that because how to store that is, so now we will be having that s dot length, right? So up to where we are not storing it, up to 26 bits, right? So up to 26 bits we are storing the characters, so we should not store our length in that 26 characters, right? So we need to left shift our length to 26 characters, then we can add it to our char bit, right? So what we'll do is we will whenever the length is in this way, so we will left shift it to 26 characters, and we will try then we can confidently store it in the 6 bits, right? In this 6 bits we can confidently store it, right? So when we left shift it 26 characters, the length if we left shift the length s dot length to 26 characters, then we can confidently store it in our char bit, right? So this is how we will be storing the uh, characters and the length in a 32-bit integer. Okay, so after that we can add it to our set, right? So set is like it doesn't have any like why set, because it may have the repeated strings, right? It may have like repeated strings, so the value will be same there, right? Whatever the string it be, it may be, the value will be same here, so it should not get repeated, right? So it should not be repeated. So for that we'll be using a set, and we will be bifurcating in this way. Okay, we'll be bifurcating the whatever the duplicate strings and whatever the duplicate characters also, we will be bifurcated using this function here. Okay, okay, now we are having a valid integer which can be said that it is a valid integer where there are no duplicate characters and where there are no duplicate strings there. So now with this we can decrease our time complexity to so much, because initially we are using only this array. This array may contain many duplicate values, many duplicate strings, and many duplicate characters, right, in subsequences. So now we are converting this array in we are also decreasing this array to a valid array where it contains where it does not contains no duplicate strings and no duplicate characters in subsequences, right? So this is how we'll be decreasing the time complexity of the so time complexity of this thing here. Okay, so and so this is a function to do this thing. This is the main step here. This is the main step to perform this operation, and this is the extra step I did here. Okay, so it may be confusing me here, but this is an extra step I did. So uh, and okay, and we have calculated the valid function here, and we need to now uh, call the recursive function here. Okay, now we will be calling the recursive function, and we will be checking how we can solve this problem. Okay, so the recursive function is this thing. Okay, so ultimate goal of our recursive function is to return the max, right? So it will return an integer only. So what we need to do here, so we need to get the here the rest is an rest is an what we can say, the rest is an resultant string. Okay, resultant integer. Okay, here the rest is a resultant integer, and whatever we do, we will be storing it in the resultant integer only. Okay, new res. Okay, we'll be giving it as a parameter, new res. Okay, in that way, like what we will be storing the sum. Whenever we store the sum and whenever we update the sum, we need to store it, right? So in the last video we were doing, we were storing the path, right? So in the path case we will be storing the res here. Okay, integer. Okay, integer. So we need to get the so from res, whatever the old characters we have, we need to get them, right? We need to add our old characters to our present characters that are in the list characters, right? So to get the old characters, we need to, what we need to do, this is the function. What it does is, so it will take a bit mask 1. Okay, and it will left shift through 26 times. So what will be the bit mask here? So 1 0 0 0 0 0. Okay, and if we do -1 here, okay, all the zeros here will turn to 1 here. Okay, so we are just doing the, we are changing the bits of that value here. Okay, so here all the zeros will turn to 1 here. Okay, by doing -1, all the bits will turn to -1 here. Okay, all the 0 bits. So with that, when we AND it, um, whatever the set bits are there, we will get the set bits, right? So for getting the set bits, like for getting the uh, set bits, like whatever the characters we want, for getting that we need to perform this operation. Okay, so and when we do the and with the rest, we will get the actual value. Okay, actual old characters. So for getting character length, what we need to do? So character length will be at the last six bits, right? So we need to right shift 26 times the rest value. When we do right shift 26 times the rest value, then we will be getting the original character length, right? So this is how we'll be getting the original character length. And initially the max will be character length only. So okay, so we will be initializing it, and we need to check, and we'll be passing our I also, right? In the solve function, in the recursive function, we will be passing that I also, I value, which goes from the each index here, from this index to this index, in this way. Okay. So if at all our I is equal to less, like size of that array, then we are not allowed to do any more operations from that, right? So we will just return our max, that is chars length. Okay, that will be our max length, right? So we need to return. So if at all we are not at that string, but we are at a valid uh, integer, like we are at a valid index, then for that index there is a value, right? There will be a value. Value means there will be a string. So from that string we need to get characters, right? Character bits, right? So for getting the character bits from it, then what we need to do? So simply this only, but in the place of this we need to place list.getI. Okay, so from that from list.getI, so list.getI is an integer. So integer, so we were storing in place of string, we were storing integers, right? So the integer will be converted. Now we'll be from that integer we'll be getting the pre-chars. So whatever the char length is, not char length, but whatever the char bits are, we need to get that, right? So for getting that, we'll be doing this operation. Okay, we'll be left shifting our bitmask to 26 times, and we'll be subtracting it with -1. Okay, and adding with the list.getI. Okay, so now is the problem. So now when we need to perform this operation, I like when we need to add this pre-cache to our new cache, right? Whenever there are no duplicate elements, right? So for example, uh, for example, there are these many, like for example, one second. For example, so 1 0 1 1 1 0 0 0. These are the res bits, like res bits we got, like whatever the character bits we have, these are the character bits we want. So in our list.getI we got some bits like this. Okay, some bits like this. Okay, some bits like this. So how to check whether there are duplicates in it or not? So when we do and of it, okay, when we do and of it, what we'll get? 1 0 1 0 1 0 1 0 0 0 0, right? So we will get an integer value which is greater than 0, right? So to check whether there is a duplicate or not, the answer should be 0, right? So if there are no duplicates in the old characters and pre characters, the what should be the answer now? So what should be the answer? It should be 0, right? So how it will be 0? Because see, uh, there is a character here. At one bit there is a character. Okay, and in the new characters also there is a bit, there is a character here. So if these two characters are same, so we can say that these two characters are same, right? In integer bit we were storing the character at a certain bit. So the characters have certain bits, right? Certain indexes of bits, right? So at same index there is a character. If there is a character at same index, then there is a duplicate, right? So we will get the answer greater than 0, right? So for getting an answer equal to 0, here if there is a character in res, there should be no character in that bit. Okay, in that index. Okay, so when we get an answer, overall answer equal to 0, then there are no duplicates. Then we can say that there are no duplicates in the rest and the new characters. Okay, in the rest and the new characters. Okay, when there is when the answer is equal to 0, then we can say that there are no duplicates in that by combining them. Okay, by combining them we don't get any duplicates. Okay, so if we don't get any duplicates, then we can add it to our answer and we can move, right? So this is same as an include and exclude function, right? So include case, right? So if we want to include this thing, we need to check, right? We need to check whether it is whether if we add that string to our answer, then if it has an duplicate characters or not duplicate characters. If it contains duplicate characters, then we don't need there is no use in adding that string to our original string, right? So this is how we'll be checking here. For that condition only we'll be checking here. Okay. Okay. If the answer is equal to 0, then there are no duplicate characters involved. So then we can happily add our string to original string, right? So to get the pre-length of this list.getI, so we will be left shifting, right shifting our list.getI to 26 times. Okay. After that, we need to add the overall combination of a res and a less.getI to the new res, right? For that, we'll be adding the old characters plus new characters. Okay, when we add the old characters plus new characters as we added in this function, okay, added as we added in this function, so same as that, we will be adding that old characters plus pre characters here. So plus we need to add the old length plus pre length, right? It will be the sum of the old length plus pre length, right? After getting no duplicates, then the sum will be old length plus new length, right? So we will be adding that old length plus new length and left shifting 26 times. We need to add this length in the last 6 bits, right? For that only we will be left shifting 26 times and adding it to our car's answer. Okay, in overall answer. So the overall answer will become, again it will become a valid 32-bit integer. So we will be passing it as a parameter here. Okay, we'll be checking it for. So we'll be doing the max. So our max will be this only. So we'll be doing the math.max, so max comma and the solve function. Okay, and solve function will be this thing. Okay, we'll be passing in place of rest. We'll be passing new s here. Okay, if at all it contains duplicates, then we can exclude that condition, right? If at all it contains duplicates or doesn't contain duplicates, we can exclude that, right? So by excluding that, the rest will be same only. So at that time also, at what will be the answer when we exclude this string by for by not including this string into our original string, right? So what will be the answer? So we will be again calculating for this one, for this case, and we will be at last we will be returning the max. So this is how we will be solving the problem here. Okay, so let us quickly check the code of this solution. Okay, so what were we doing? We will be taking set here. So set for storing the integers, so, and bifurcating the duplicate strings and duplicate characters. Okay, for that only we are using set, and to pass it as a parameter in the solve function, we'll be storing the whatever the set values. uh, I said right. We need to store. We need to convert every string to this integer string, right? Integer thing. So for that only, we will be taking every string from an array. We will be going for every string in an array, and we will be converting that string, and we will be adding it to the set here. Okay. If at all it does not contain any duplicates, then we will be adding it to a set here. Okay. So this is how we will be. We have already discussed this operation here, and this is how we will be calculating the integers for every string here. Okay, and we will be copying it to the list here. Okay, we will be copying every set integer to a list. So, what set contains here? A valid strings, right? Valid integers where there are no duplicate strings and no duplicate characters in each string, right? So now we will be passing this list as a parameter and 0 as an index and 0 as a res, that is path. In the previous case we were passing the path as a string here. Now we will be passing integer as a path here. Okay, So with this function, we are not able to track the path here, but we will be trying to solve the problem, trying to reduce the time complexity, because ultimate of our ultimate goal is to get only the max value, right? So what length value, right? Not the path, right? For that only we will be passing the integer only. Okay. So, and one more thing what we did is one more thing what we did here is we were storing the length of the string in the resultant bit only, right? Resultant integer only, right? So this was a plus point for us in this here. Okay, this was saving a lot of space here. Okay, space also it is storing here. Okay, so we were using the proper space here. Okay, proper space of an integer. Okay, and as usual, this is the function we will be doing for calculating the max value, and this is how we will be solving this problem. And so what will be the time complexity of this problem? It will be pure 2 to the power of whatever the length we are having, 2 to the power of maximum length of that list here. Okay, 2 to the power of maximum length of the list here. Okay, so 2 to the power of maximum length of a list. Okay, and we were also, so okay, 2 to the power of will be the maximum length here. Okay, maximum length of the list, that are maximum non-duplicate strings here. Okay, that will be the time complexity here, and space complexity will be recursive space we will be using here. Okay, it will also be uh, how many calls will be taking, it will be taking almost 2 to the power of m only, 2 to the power of m. The depth calls will be like it will be around we are using a set, right? So, we are using a set here, so for set we will be using at max, if there are no duplicate strings in the ARR, so at max we will be using big of n only, right? Big of n space here, right? And for recursive space here we were going to the depth of tree, right? So depth of a tree, so the recursive call space will be the depth of the tree, right? So depth of the tree or height of the tree, maximum height of the tree, right? That will be the space complexity. Okay? And this is the solution here for calculating the maximum length of a concatenated string with unique characters using bit manipulation. Okay, and thank you for watching this. Please subscribe to the channel, eat code and see. Yeah, thank you.